like to say a few words today about my Celestron 130 Astromaster telescope. When I first became interested in this hobby, I did some research, and this was the scope I figured I wanted to start with. With the right ascension motor drive, the Celestron Astromaster 130 EQ MD, equatorial mount motor drive, was the one I figured I wanted to buy. My interest was Celestron. I only had a $300 budget, and this cost $300. Still does today, by the way. I knew it wasn't the best Newtonian reflector in the world. If it was, then there'd be no need for telescopes that cost $1,500, $2,000, $2,500. This was what I could afford. And it was from a good, reliable company. It was for beginners. I figured I could buy this and learn some of the basics, how to use an equatorial mount, how to take the back of the telescope off and clean the mirror, things like that. How to put a center mark on the mirror so I could properly color. Basic things. And then over a year or so, save up a little more money and maybe upgrade and buy another telescope. I went online to chat rooms and YouTube video sites and asked what people thought about this, and they all said, "Oh, it's a piece of junk. Don't buy that. It's a terrible telescope. You should buy a Dobsonian. Everybody should buy a Dobsonian as their first telescope." I thought, well, Dobsonians are not particularly good for photographing faint, deep sky objects. They don't have tracking. But everybody kept saying that. Oh, and they were saying, aperture is king. Buy the biggest Dobsonian you can. So I bought a 10-inch Dobsonian. I drug it out here in the yard one time, was down on my back 3 days. I gave the telescope away the next day, and I was out $1,000. And that's when I learned, just because somebody says to buy something, that don't mean you should buy it, because only you know what you want out of the instrument. I eventually did buy this, and 19 other telescopes. I'm way over budget at this point. And let me tell you a little about it. This has a 650 millimeter focal length and 130 millimeter aperture, which makes this pretty much a standard 130 millimeter telescope. Most 130 millimeter Newtonians have a 650 millimeter aperture, or focal length, which gives them a focal ratio of f5. It's a fast telescope, which is good for photography. And it does not have a Burne-Jones lens in it, like all the other Power Seeker and Astromaster reflectors. They're all designed just like all of the Astromaster and Power Seeker refractors are designed for one vector. Interplanetary work with the moon and 4 or 5 planets you can see with them, because they figure that's what beginners want to see. To do that, you want as high a focal length as you can get, so you can get the maximum magnification out of the provided eyepieces. This, along with the Astromaster 102 millimeter refractor, are the only 2 general purpose telescopes in the whole, in either line. This does not have the Barlow lens in the bottom of the focusing tube. You can stick a Barlow lens in here and get a great, a long focal length if you want. But you really can't take the Barlow lens, not handily at least, out of the other Newtonian reflectors in these 2 lines for work with deep space stuff. Deep space stuff, you generally don't want a Barlow lens because it's faint. The Barlow lenses absorb a lot of light, so you want a naked one. All right. It has a red dot finder, which is the kind of the standard they use in this series of telescopes. It's got these rings here which allow you to rotate the optical tube. So if you have more weight on one side than the other, you can move it back and forth. And if you want to move this up or down for pleasant viewing, you can do so. By the way, if I were viewing this, I'd actually be on this side, because this is where the slow motion control is. But if I were on that side, I'd be looking that way and you wouldn't be able to know what I was saying. It comes with two eyepieces, a 10 millimeter eyepiece and a 20 millimeter directing eyepiece. Directing eyepieces do the same thing that directing diagonals do. They allow you to, normally with a telescope, everything's upside down. Directing eyepieces turn everything back right side up. I have no idea why they would want to put that in a Newtonian reflector on an equatorial mount. This does not do all that well for terrestrial use. It's made to look up into the stars, and there is no right or upside down in the stars. But that's what it comes with. The focuser is a nice smooth focuser. It lacks the lockdown screw, thumb screw, that I always want on a telescope. The equatorial mount isn't bad. It's a pretty good beginner's equatorial mount. First, this is $300 all told. The next step up from here, from the if you're looking for a manual telescope, not computerized, the next step up from here is the Celestron 150 millimeter XLT, Omni XLT. It's $700 for a manual mount, CG4 instead of a CG3, 150 millimeter. That's better in every way. Optical tube's better, mount's better, everything is better, and it costs a lot more. Oh, this is $250 without the motor. $250 as opposed to $700. And not everybody who gets into this hobby has $700 laying around. Girlfriend wants stuff, landlord wants rent. A lot of things you can spend the majority of that $700 on. If you buy this and you're serious, you will want to take this off the back of the mirror cell off the back of the telescope. Watch the video I made on how to put a center mark on the mirror, and follow the instructions. Put a center mark on there, then buy you a laser collimator so you can collimate it. None of the Astromaster or Power Seeker reflectors have a center mark in the center of the mirror. You really need that if you want to do a good job in collimation. And from what I've seen of people on videos, to begin with, to point the thing, they pick it up, turn it around, and kind of face it in the general direction and wrestle it around. A lot of people don't balance it, polar align it, and then star it. They just use it like they would a handlebar mount. And that's a poor choice. If you're going to buy one of these, you need to learn to use the equatorial mount the right way. There's a lot of videos on it. I can make some if you want some. And you'll want to mark this mirror here in the back. If you mark the mirror in the back, do a laser collimation, you'll get really good views. There are a few websites, or a few channels on YouTube where people are doing it in a professional way. They collimate it carefully. Their stars are all pinpoint. Everything's beautiful. And then there's a whole bunch of channels where, if you look at the stars through here, they all look like comets. They all have tails, and the planets are all blurry, unfocused. That's not the focuser, that's the collimation. The mirrors are not properly aligned. If you're going to buy a Newtonian reflector, you have to put a dot in the center, Then you have to learn to collimate it, line the mirrors. By the way, I can collimate this in less than 60 seconds. What I do is I take this out, pop the laser collimator in there, turn it on, adjust a couple things here if it needs it, adjust a couple things here if it needs it. Less than a minute, it's collimated and you're perfect to use it. I always check the collimation, the mirror alignment, before I take any telescope out to use it, if it's a Newtonian reflector. They're easy to collimate. A Schmidt Cassegrain, on the other hand, is a real booger to collimate. I can spend hours getting that thing collimated, and then after it looks collimated, I have to put on a tri-batinol mask and fiddle with it for more hours still. These easy. Once you get used to it, you can collimate the thing in less than a minute, and they don't have to be collimated all that often, but you should check it every time. Yeah. So if you put a center dot in, get your laser collimated, the center dot, well, you can see in my video, I made the one I made for the video cost $8. I bought some arts and crafts stuff. Laser collimators run about $25. For about $15, you can buy a Cheshire eyepiece. You can collimate with that. That's a little harder, and if it doesn't have a center dot, it's not terribly accurate. And if it has a 1 1/4 inch focuser instead of a 2 inch, it's not so accurate. I'm thinking of doing a video on how to use a laser collimator and how to use a collimation cap and Cheshire eyepiece if there's any interest. If there's not any interest, I won't. This was the scope I first wanted when I got into this hobby. With the this, by the way, is a pretty crummy right ascension motor drive. It's a $50 motor drive. The next cheapest one's like $180, and it's not very good. I paid $270 for the one I've got on my CG4. It's good, but this will do the trick. And if you're trying to take 3-minute exposures and you want to take it like for 4 or 5 hours, this won't do very good. But if you're only trying to take 10 or 15-second exposures for 15-20 minutes, this will do fine. At least that's what I found. And you can get some really nice deep space pictures with this motor drive and this telescope. Anything else? Got a mirror. Got 2 of them, secondary and primary. I've got that. It's got slow motion controls. If you don't put the motor drive on, what you do is you slew over to the target, and you if you got it properly polar aligned, the balance and everything, you just use the one right ascension slow motion control, and you can follow it. In fact, you can actually do astrophotography without this right ascension motor drive using slow motion control with something like Sharp Cap Pro. The Sharp Cap Pro tries to align all of your subframes, so you turn it on, take some pictures, it's moving, then you pause it and use your slow motion control, move it over a bit, and just keep doing that for an hour if you need to, and you can get some fairly nice pictures of that if you don't have a motor control. If all you're interested in is viewing, this will give you good views, but you have to learn to use it. But if all you're wanting is to go out, not have to collimate, not have to polar align, not have to clean the mirror, just crank it up and look at the sky, and look at maybe the moon. Ooh. A few nights later, no homework, clear sky, go out and look at Jupiter. Ooh, bands. A few nights later, go out and look at Saturn. Call your brother, look here, it's got rings. And after a week or two, you've pretty much seen everything there is to see in the solar system, and you put the telescope in the closet. You don't want this one. You want something like the Astromaster 70mm long tube with a handlebar on it. Takes no time to learn to use it. You can see some nice stuff. This is for the more serious amateur astronomy. Yeah, and at least that's from my experience, what I think. So, until I see you again, happy trails.